Welcome back, learners. Today I'm going to introduce you to preparation of carbon dioxide. Remember, in our previous lesson, we talked about allotropes of carbon, oxides of carbon, preparation of carbon 4, and now is preparation of carbon 2. Carbon 2 can be prepared using different methods. Number 1, we can dehydrate methanoic acid using concentrated sulfuric acid, or ethanoic acid, which also we call it oxalic acid. For this setup, we are dehydrating methanoic acid using concentrated sulfuric 6 acid. As you can see, we have our dehydrating agent and we have our methanoic acid. So what happens is, we only want to obtain CO, or carbon 2 oxide. The equation is, we have methanoic acid dehydrating using concentrated sulfuric 6 acid, and what we get is CO plus water. So in other words, this is how we write methanoic acid. Remember, it is in solid form, so here we use Cong sulfuric 6 acid to get CO plus water. This is gas, this is liquid, and it is different when we compare, or when we want to prepare carbon dioxide using ethanoic acid, like for this case. For ethanoic acid, you have an additional product which is CO2. So if you can see, we have concentrated sulfuric 6 acid from above, then this is our oxalic acid, which is also ethanoic acid. So at this point, we'll have CO2 and CO, these two produced, and therefore, since we want CO as a product, it means we must eliminate CO2 by we pass it through a basic solution, strong basic solution. For example, you can pass it through sodium hydroxide. Remember how we were testing the presence of CO2. We bubble it through calcium hydroxide. It formed a white precipitate, and therefore for this case, we are dehydrating ethanoic acid, or what we call oxalic acid, and thus we will obtain CO2, CO, and water. That is why we have ethanoic acid. We are dehydrating using concentrated sulfuric 6 acid, and what we obtain is carbon 2 plus carbon 4 plus water. And we are interested with obtaining CO. So this is how we write ethanoic H2 C2O4, which is solid, then sulfuric 6 acid, this is concentrated, to obtain CO plus CO2 plus water as shown above. So the gas which is CO2. I've said, sorry, we pass it through carbon, we pass it through a concentrated base or a strong base, which is sodium hydroxide, as shown here. Then from there, the other gas, which is CO, we collect it via over water method. So those are the two ways on how we can prepare CO, and maybe we can look at the other setup, which is also the gas may also be prepared by passing carbon dioxide over heated charcoal, as shown in the setup below. And in this setup, what you should note is we are preparing CO and at the same time testing the reducing property of CO, not CO but charcoal, sorry, because which is the same as carbon. Because if you can look, if you can see well, we have CO from this point and then it is passed over heated charcoal here. So it means CO2, carbon dioxide, which is a gas, plus carbon, which is solid in that case, CO2 is reduced to CO. Okay, we are reducing CO2 to CO. And that's why we are saying this method can also be used to prepare CO. So you pass CO2, we reduce it to CO, and then this sodium hydroxide here is, its purpose is to absorb the CO2, which might not have been reduced by charcoal at this point. So we are using sodium hydroxide to trap this CO, the excess CO which passes without reacting or being reduced by charcoal at that point. And then CO, it comes to this point where we collect it using over water method. And it is easy. It depends with how the examiner brings the setup. So the other point, the other setup here, it is the same. If you can see, we have dry carbon dioxide here. Then this is charcoal, as we said. So at this point, we are also testing and reducing property. At the same time, uh, absorbing or preparing CO this point. So potassium hydroxide is used in place of sodium hydroxide, as we said, and its purpose is to absorb the excess CO2 which might have passed here without being reduced by charcoal.